Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be talking a little bit today about Docker, LXD and LXC, which are a different kind of a container. And then we're going to talk a little bit about Incus as well. So let's get started and dive in. There are basically two types of containers that exist in the world today. There's the system container. The system containers are very similar to virtual machines or even bare metal. They run a full copy of the operating system inside the container. And those would be more like LXC. Application containers are also called process containers. They're really meant to package and contain a single application or a single service for each containers. In the case of application containers, those can have, as you can see here, they can have on the left, those can usually are having either one app or one service on them and make them so that they're stateless. But it has a container engine, usually, and it's Docker in this case. There's usually a container runtime, which today is run C. However, in the beginning, Docker used to use LXC as their container runtime. Then you have the host OS, the host kernel, and then whatever infrastructure that both the host needs as well as what the containers needs too. And the system containers, yeah, you can have multiple applications on those. They have their own guest OS. So if you're looking at this, you're probably thinking, wow, that's kind of a virtual machine. And you'd be right, it is. You have LXD, which is the daemon that controls creation and starting and stopping of them. LXC is kind of, you can think of that as the runtime for the system. And then you have the host OS, the kernel, and then the infrastructure, just like you did before. One of the advantages of Docker, and we'll take these in reverse order. So what are the advantages to using Docker? Docker's portable. The whole idea behind Docker was WOM, works on my machine. So it also has integration with other pieces of software like Circle, CL, VS Code, GitHub, that kind of thing. It's packaging and sharing of applications with Docker. And that includes all the dependencies that those apps need. So, yeah, it's all together. And you just hand it off, you run it, you're done. It just works most of the time. So multiple versions support of containers can also be done. However, just like all things, there are disadvantages to Docker as well. And these are kind of my thoughts in working with it for a number of years. I've heard this top one shared with other people, but it lacks the support for enterprise level applications. It can be a challenge to manage unused images in Docker, as probably some of you have seen, that over time you get this collection of obsolete images you're no longer using. At some point, you got to go back and clean all those out. Docker Hub retention policy can be weird at times. I remember seeing some of the images that we were using would just disappear for no apparent reason. The data storage and volume management, I think, really needs to be more simplified. It isn't that it doesn't work. It does. It's just more complicated than it needs to be. And the problem that you run into is when you need to expand it because things grow over time and what you thought was going to be the maximum amount that you needed in the pool changes. And so you need to be able to update that. And it's not an easy thing to have to manage on Docker. So LXD, some of the advantages of it is it can integrate to cloud platforms. It has tools for Ansible and Mass and Juju, Packer, Terraform, Puppet, Bolt, and so forth. It has things that it can help manage the LXD clusters. Device pass-through exists for LXD, for USB devices, graphics processors, disks, NICs. Also, you can snapshot a running container, and you can create virtualized Linux environments. There's also some problems with LXD as well. It's not an easy tool to use, and a lot of times, I'm guilty of this too. When I first started using it, I'm thinking, oh, this is like Docker. And so I started pushing Docker images into it. Bad idea. Don't do that. The problem is that Docker is a totally different type of container, and it doesn't work. You may find issues doing that. I found lots of issues with things breaking. And what I'm telling you is spend more time in the book and learn it, understand it before you start thinking, oh, this is just Docker. It isn't just Docker. It isn't at all. So LXD does not really provide an application delivery framework. So you've got to kind of manage that on your own. Even though it's weird that LXD appears a lot in CI/CD. It isn't as much as Docker does. Docker is way more popular, but it does show up. And it's kind of weird that it would be used in an application delivery framework when that's not exactly its cup of tea. And what do I mean by that? Well, it's really tuned to delivering a template. Now, Turnkey is really trying to turn that around. So they're starting on application delivery templates, or you can go and pick out one and you can download it and you'll have your application up and running. I mean, it's good that some people are working around this issue. Copying LXD containers between systems, that's not an easy thing to do either. A mixed operating system like data centers where you have Windows and maybe you have a few instances of Mac OS and a whole ton of Linux machines. It's difficult to operate across them with LXD because it's not supported equally across all of those platforms, whereas Docker is. Not saying you can't do it, just saying you might regret doing it with LXD. So where are they similar? They both share the Linux kernel with the host. They both have tools to build your storage and interfaces, set up your networking and manage your containers. They both use a services-based daemon runtime for managing the start, stop, and restarting of containers that have broken or failed. And they both offer good documentation. So in my experience, managing LXD is more like a virtual machine. So where does LXD and LXC shine? So the applications that are heavily resourced, they have heavy resource utilization. Yeah, LXD and LXC works well. Virtual desktop infrastructure, also system level testing. Use cases for Docker, microservices architecture. Docker is good at continuous integration and continuous deployment. It's used a lot in those environments. DevOps environments, you'll find it paired up with a number of technologies, Chef being one of those. Incus, what is it? Well, it was named after cumulative bus Incus or Anvil Cloud. It's a community fork of Canonical's LXD. And the reason for that fork was Canonical took over the LXD project from the Linux containers community. And the developers thought, well, that means a large corporation is going to drive this the way they want it, and they are. And so they wanted to make sure that they had a means to take what they had built and continue to build it the way they wanted, independently of any input from a corporation. So yeah, they wanted to be able to have their independence, and so they broke this off. But the main aim of this fork is to provide a real community project where people are welcome to join. There's no one single commercial entity that's in charge of the project. Incus is a next generation system container, and it also contains a virtual machine manager. They realized that, hey, these things are so close together, let's put them so that we can generate virtual machines that run under KVM, or we can use system containers that run under the host. Incus provides a unified experience for running and managing full Linux systems inside of a container or a virtual machine, your choice. There are still business reasons to use containers, and there are business reasons to use virtual machines. And there probably will be for as long as there are applications that fit in those two diverse pipes. So Incus is really built around the REST API. It scales from a single machine. They do support clusters, so you can use clusters in order to scale up from the single environment. The other thing is, and I'll show you this, I hope, is the Incus benchmark. So Docker and LXD offer advantages depending upon the workload. Does this sound like a common theme on this channel? I mean, it's always, you start with what your workload is first, and then you figure out what it is you need. You don't go the other way around. You don't go, oh, I'm just going to use Docker and try to fit that round peg in a square hole. Docker has its places where it does great and it shines. And LXD has its places where it does great and it shines. So Docker works best in microservices deployments. LXD works best in multiple application deployments. If you need to run Docker on Proxmox, use a virtual machine and not a LXD container. So that's all I had. Let's go look at Incus a little bit. I'll also do a short setup on LXC, and you can see how that's done under Proxmox. The very first thing I want to do is go into Proxmox, and let's create a container there, create CT, which these are LXC containers. So, all right, so how do you do that? Well, the first thing you need to do is we want the one with the templates first. So if I open that up, I'll see that I have 3 different templates in here already. And where those came from was this list. If you click on the templates button, it'll bring down a whole list. These are the ones that are supported by Proxmox and also LXC, but these are the turnkey ones I was talking about. These are application containers. So you have things like Trax and ZoneMinder and Game Server and just all kinds down here. But as you can see, there's just, Turnkey is doing a lot of work with that. But let's just keep things simple today, and we'll choose one of the ones I don't already have, which is Debian. So let's go ahead and get that one, and I just download it. We can check the status to make sure that it is, and it is. So all right, so now I have one here. I'm ready to go actually create one. So I can go up to the create CT, create a template, container template, and we'll just give it a host name. This will be the name that appears out in the data center list. So we'll call it, this will be the password that's for root. And then if you have a SSH key that you want to load in, you can. I don't, so we'll go ahead and we'll tell it that, you know, where we have our templates located is on that local folder down there. That's the one we just brought down. So we'll go ahead and grab that, and then we'll go over here next. At this point, it's more or less like setting up a VM. Now you do have some options here for. Let's go ahead and say no A time. Yeah, it's not going to make a whole lot of difference, but that's okay. We'll give it, you don't need a lot of cores for these, nor do you need a lot of memory. Let's try just 1024. And my network options, I do want DHCP for this though. If you wanted, you could give this a static IP address. And then you'd have to specify the CIDRL as well as your gateway. But this way it'll pick up not only all that, but also my DNS entries will be picked up from there as well. So I don't need to do anything with that. So I can go ahead and hit finish. We'll let it build out. I believe it's done. Yep, it's done. So now we should have it in our list here. So let's go ahead and start it, and then we'll bring up our console. And it's waiting for a login. And I just use the same password I created it with. And that's it. At this point, we can start checking things over. Let's see how much, yeah, it's got tons of memory. You can do the usual stuff here if you want to update. It's just giving me a warning that since that template came down, that the Debian team has upgraded the version from 12.2 to 12.4. And we'll go ahead and update our container. Because remember, this does have its own operating system. We'll go ahead and reboot it. So at this point, you could start to load out whatever applications you want and begin using this as you would any other type of resource on your systems. The kernel we're using is 6511-6 PVE. That is the same version as the kernel that is being used by Proxmox. So yeah, that's what we meant by it sharing the kernel. Even though the operating system is distinct, the kernel that it's using is the one from the host. So yeah, all right, that's all there is to that. Let's go on and let's go see what we can learn about Incus. The first place I'm going to go is out here to the linuxcontainers.org group. You can also go online and try it if you don't want to bother to install it on your machine. So yeah, and they give you some information here about what it is, how to get started, and we can go to the manual that it's in the GitHub. That'll help you get started with it. But pay attention, because down here is actually how to install it. So you'll need this information first. And they have instructions if you're on Debian or Gentoo or NixOS on how to install Incus. So also they have other information if you're on Mac or Windows. You can also install it on those platforms as well. I have it installed. I've gone through the install process. So if I just put in Incus by itself, it'll give me the list of commands. And it's kind of, if you're looking at Docker or you're looking at LXC, you'll probably say, oh, this is very familiar. I've seen these before. So let's see what version that we're on first. I think it's .3. Yeah, both the client and the server version is .3. The first thing that you would do after installing is you would do an admin. You can, if you want, you can put a help command behind that. And you'll notice that there's one that says auto, one that says you can dump the YAML config to standard out, and there's a minimal. You can also specify your own network address, your network port you want to use. So you can also specify where your storage locations are as well. So what they recommend in the manual is to just do a minimal. Now I've already done this. Once you've done this, it will create a bridge that has your IPv4 and your IPv6. Now, you don't have to do these if you don't want to, but I do, because I use IPv6 here in my lab. Just like when we were out in Proxmox, the first thing we need to do is to get a list of images. So how do I do that? Well, I'm going to use Incus list. And the next thing I need, if I look at the help, is I need a remote. So what is a remote? A remote is a place that holds the templates for your container images. So one of the ones that we have defined is this. And yeah, there's a ton of them. Yeah, there's all kinds. And you'll notice that in this column right here where we see container in caps, some of these are for virtual machines. And so yeah, we can you can install a virtual machine. Now, in order for that to work, your BIOS has to be set up just like it would for any other virtual machine. You have to turn on the virtualization options in your BIOS in order for this to work. If you do not, if you don't have that device in dev, KVM, then it's not going to work. So, but you can get the container to work. I know what one I want to use, so let's go ahead and Incus has two different options. I can either do an init, which will allow, I can either create the container or the virtual machine, or I can launch it. I can create and launch it. So if you init, it doesn't start it. And if you launch, it does. So that's what we want to do. So the next thing you want to give it is the remote and the name of the image you want. And the way you specify the version is you'd say Ubuntu and then you say 2204 for the with a slash. And we'll put in, this will be, we'll call it first. There's a tutorial that's in here. I'm just following that. So if you want, I'm not going to go through this whole thing. I'm just going to show you kind of some ideas here that you can do. So it's creating it. Now on yours, the first time that you bring down Ubuntu 2204, it has to download it and then it will install it. So the first thing I can do is I can do a list. That'll show you installed and its state. So there's my container. It's running. There's the IPv6 address, and you'll notice there's no IPv4. You can also copy one to another, so we can do, you can copy from the first over to the third. And it'll show it as stopped, but you know, we can go ahead and start that. We can do. Now we have all three of them running. Let's create a VM before we go. Let's go back to this one. All you do to specify a VM is just put a tac VM at the end. And now we have a virtual machine. So if I do a list, this time instead of a container, it'll show I actually have a VM here. You can, let's say we want to get rid of one of those. Let's try second. So if it's currently running, it's going to say, hey, it's running. So your choice is, I can type stop. And now I can delete it. I'll go ahead and get rid of third too. Or you can use the force option as they suggest there. And that will go ahead and delete it anyway. So if I do now I just get the one container and the one virtual machine. So the other thing I wanted to show you was the benchmark. So out here in opt, there's a directory called Incus. And in bin, you'll notice that there's one called Incus benchmark there. So again, just like before, we can list it. And they give you some examples here. So here's one where we're going to spawn 20 containers in batches of 4. So this one is going to measure the time it takes to create the container and then run it. So that's going to be the slowest of them. But we can go ahead and do that. Now, one thing I would like to do, though, well, maybe it's all right. Let's go ahead and paste that in, and we'll let it run. This will take a little bit because it is creating 20 containers. So in about 50 seconds, it created them. One of the other options is to delete them. So we can see how long it takes to actually destroy 20 containers. I'm not suggesting that this is the fastest. I mean, it isn't. It's not the fastest I have ever seen, but it's not bad. So yeah, that's as far as I'm going to go today. So anyway, that's all I had for today. I hope you enjoyed this video. And if you did, please like and subscribe. Hope to see you all again real soon. Bye for now.